Okay, so we're going to continue 3.5 with now looking at horizontal asymptotes. What I have listed here are the ways that we identify horizontal asymptotes. The way we do this is we compare the degrees of the top and the bottom. So we look at the degree of the polynomial in the numerator, and we look at the degree of the polynomial in the denominator. So if the degree of the top is less than the degree on the bottom, then there's a horizontal asymptote at y equals 0. Okay, so if we go back and we think about f of x equals 1 over x, okay, the degree of the top is smaller because the degree of the top is 0 and the degree of the bottom is 1. That's why that has that horizontal asymptote at y equals 0. Okay. If the degree of the top is greater than the degree of the bottom, then there is no horizontal asymptote. So if I have something like g of x equals x to the fourth plus 2 over x to the third minus 1, there's no horizontal asymptote, okay, because the degree of the numerator is 4 and the degree of the denominator is 3. Okay, the top has a greater degree than the bottom. There's no horizontal asymptote. Okay, if the degree of the numerator or the top is equal to the degree of the bottom, then the horizontal asymptote is y equals the leading coefficient of the top over the leading coefficient of the bottom. So for here, if I had this h of x equals 2x squared minus 5 over 3x squared plus 7. My horizontal asymptote, since they have the same equal degrees, would be the leading coefficient of the top, which would be a 2, over the leading coefficient of the bottom, which would be a 3. Okay, so this one's actually a lot easier to determine than the vertical asymptotes. So we're going to do this kind of quickly for these next examples. We're going to identify the horizontal asymptotes if there are any. So for this first one, f of x equals 3x over x squared minus 9. All we got to do is look at the degrees. The degree of the top is 1. The degree of the bottom is 2. So the degree of the top is less than the degree of the bottom, so the horizontal asymptote is y equals 0. Okay, so for the next one, that one was nice. This next one, f of x equals 3x squared over x squared minus 9. The degree on the top is 2. The degree on the bottom is 2. Those two are equal. So that's this situation. If they're equal, then the horizontal asymptote is y equals the leading coefficient of the numerator, 3 over the leading coefficient of the denominator. That would be a 1. 3 over 1 is just 3. So that is our horizontal asymptote. Okay. And then for this third example, f of x equals 3x to the third over x squared minus 9. Let's pick a different color for this one. We have the degree on the top is 3, the degree on the bottom is 2, the degree on the top is greater than the degree on the bottom, so therefore there is no horizontal asymptote. Okay. Okay, so this next section is going to be going over how to actually graph rational functions. I know that earlier in this chapter, we were kind of estimating, giving good estimations of what these things look like for polynomials, and we're going to kind of do the same thing for rational functions. So first things first, we're going to have to determine if there are any vertical asymptotes and graph them, and then we have to determine if there are any horizontal asymptotes and then graph them. Okay, so that's the first thing we're going to want to do with these rational functions before we graph them. Then we want to determine any intercepts. Okay, so we're going to determine the x-intercept by setting the numerator equal to 0 and solving for x. So when does a function equal 0? That will give us our x-intercepts. And then we find the y-intercept by finding what f of 0 is equal to. Lastly, we're going to want to make sure that we plot at least 2 points to the left and to the right of each vertical asymptote. So that could be a lot of points depending on how many vertical asymptotes there actually are. The other thing to note is that some of these points will actually come from those intercepts that we find. So some will come from up here, okay? But some will not, and then you just have to pick values of x to evaluate the function at to find your other points, okay? So let's take a look at an example. Okay, so we have this function, f of x equals x squared plus 4x minus 5 over x squared minus 5x minus 6. The first thing we should really do is to take a look at the original function and take the numerator and the denominator, and we're actually going to take some time and factor those. So looking at the numerator, we're going to get x minus 1 x plus 5, okay? Then we're going to get for the denominator, x plus 1, x minus 6, okay? So that's going to help us figure out a lot of this information. Now, on this page, I'm kind of just going to show my work, and then we're going to show how to actually graph it. All right, so for now, we're going to take a look to figure out what our vertical asymptotes are, and then we're going to graph them as dashed lines. So my vertical asymptotes I determine by taking the denominator and setting that equal to 0. First, I want to check nothing cancels with the factors in the numerator, so those are my factors that I'm going to set equal to 0. X plus 1 equals 0, x minus 6 equals 0. So I have vertical asymptotes at x equals -1 and x equals +6. So those are my vertical asymptotes. Okay, so to find horizontal asymptotes, remember I look at the degree of the numerators and denominators. When those two degrees are equal, okay, like in this case, the degree of the numerator is 2 and the degree of the denominator is 2, then my horizontal asymptote is going to equal y equals the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 1. So therefore, 1 divided by 1 is 1. So we have our vertical asymptote, and we also have our asymptotes, 2 of them for vertical, and we have our horizontal asymptote. Okay, so we're like a quarter of the way there. The next thing we're going to need to do is we're going to need to find our intercepts. So we're going to determine the x-intercepts by setting the numerator equal to 0. So the numerator, that's why it's nice to have already factored it out. We just need to take the numerator and set that equal to 0. That's how we're going to find our x-intercepts. So we take x minus 1, x plus 5, set that equal to 0. That's equal to 0 when either one of these factors are equal to 0. So our x-intercepts are going to be x equals 1 and x equals -5. Okay. Then we're going to find our y-intercept. I need more colors. We're going to find our y-intercept by doing f of 0. And I'm going to take this up. Actually, I'm going to do it in the factored form. That's totally fine. I could also do it. It doesn't matter. I can do it in the factored form, or I could do it from the original function. It's okay. I'll do it from the original function. I just changed my mind. 0 squared plus 4 times 0 minus 5 over 0 squared minus 5 times 0 minus 6. So all these things cancel. Nice. And so I'm left with -5 over -6. Those are just going to be zeros. So it's just 0 minus 5 and 0 minus 6, which gives us -5 over -6. -5 over -6, negative divided by negative is positive. So my y-intercept is the lovely fraction 5/6. Okay, so now we're going to graph this rational function. I've already drawn in the vertical asymptotes. This first one right here is at x equals -1. This one right here is at x equals 6. Then I drew the horizontal asymptote in green. We found that that was y equals 1. Now I'm going to plot the intercepts that we found. We found that the x-intercepts are at x equals 1, right here, and x equals -5. So -1, -2, -3, -4, -5. So those are my x-intercepts. Now my y-intercept was at 5, 6. Okay, so in this case, this one is right here. Okay, so when I determine other points to plot, I already got 2 in between here. I might want to get maybe -0.5 just to really feel like what I know what's going on with this function. But I might want to get another value. Let's try f of -2. Figure out what that's going to be. I'm definitely going to need to do 2 over here, so I might do f of 7 and then f of 10. See where those are to get a bit better idea as to where where this function is. I might want to do f of -0.5, and you can use your calculator to calculate these by putting each one into the original function. So I'm going to take a moment off screen to do that so we can get those values. And then we'll know what's going on. And for posterity's sake, I might also do f of -10, just so I see where it is. Okay. Okay. So I used the calculator, my scientific calculator, to substitute in each of these values. I also added one because I was kind of like, this middle section is kind of freaking me out. I want to make sure I graph and plot this properly. So I did f of -1/2 and got this 2.0769, which I plotted right here. Okay, but then I also was like, well, what's happening over here closer to the x equals 6 asymptote, this second vertical asymptote? So I also added in f of 5 and got that that is equal to -6.66, repeating. So I've gotten all these different points, and it gives me kind of a sense of what's going on with this function. So starting from this point right here, the x-intercept at -5, I'm actually going to connect that to this point that I found over here and show that that's going to get really close to that asymptote. It's going to stretch over to this point and get really, really, really close to that asymptote. Okay. Then from this x-intercept at 1, I'm going to connect those points. Okay. And then this is going to come down and go through that point right there. Okay, and then these 2 points at f of 7 and f of 10, I'm just going to connect like so. Ooh, not like that, like this, and show that it's going to get close to each of those asymptotes. And that's as precise as you need to be. Okay.